Hi, I'm EJ. Let's talk about the pharmacodynamics of antacids. Antacids are over-the-counter medications that are used to treat heartburn, functional dyspepsia, duodenal ulcers,
and
gastroesophageal reflux disease. Antacids do their work by neutralizing acids found in the gastric juice. Let's see what we're up against. Gastric juice secretions can have pH as low as 0.8, bringing your total stomach pH to 1.5 to 3.5 pH. Ultimately, it makes an aqueous solution of renin, pepsin, hydrochloric acid, and mucus, as well as electrolytes and other enzymes. There are many different kinds of antacids on the market. We're going to look at 4 different antacids. Malonol, which is comprised of aluminum magnesium silicate, or amosylate. Acetylone, which is comprised of aluminum hydroxide and magnesium oxide. Gavison, which is composed of sodium bicarbonate and sodium alginate. And Malox, which is comprised of aluminum hydroxide and magnesium hydroxide. First, we'll take a look at malonol. Malonol's active ingredient is amosylate, for which the exact chemical composition seems to have different answers from different sources, but is definitely a polymer containing magnesium oxide and synthetic aluminum silicate, and is described as having a neutralization capacity 1.5 that of sodium bicarbonate and half that of magnesium oxide. Whichever composition is correct for amosylate, it hydrolyzes into aluminum magnesium ions, as well as conjugate base for silicic acid, bonding the hydrogen and chlorine ions. We take a look at acetylone, which uses aluminum hydroxide and magnesium oxide, which neutralize 3 and 2 hydrogen ions respectively. Now you might wonder why aluminum and magnesium are both administered at once. More on that in a bit. Now Gaviscon has an interesting mechanism to it. It uses sodium bicarbonate and sodium alginate, and as the sodium bicarbonate neutralizes some hydrochloric acid, the sodium alginate does something a little different. Sodium alginate is a linear polymer derived from seaweed.
when the calcium from the sodium bicarbonate reaction ionizes, it fits the chains together, forming a gel. The carbon dioxide resulting from the same reaction raises the gel to the top, forming a barrier to protect the esophagus. Finally, we have Malox, which is yet another variation of the magnesium and aluminum combination. Since aluminum compounds induce constipation and magnesium compounds induce diarrhea, they're administered together to try to cancel most of these adverse effects. Okay, let's do a sample calculation to see just how much hydrochloric acid we can neutralize. We have experimental data for all these antacids, so let's try to work out Malox and see if we match the data. 10 milliliters of antacid was used in the experiment, so we'll match that. We have 400 milligrams of each compound, and dividing by their molar masses gives 5.1 and 6.86 millimoles of aluminum hydroxide and magnesium hydroxide respectively. Stoichiometric calculations yield the hydrochloric acid neutralized, and the total sum seems to be 29 millimoles. Sure enough, we can see in the table for Malox we have exactly... Okay, hold on a second. Got my glasses. Yep, that's 257 millimoles. Well, that's unexpected, but science happens. Let's take a look at the literature to see if we can find any clues about how the experiment was conducted. So we can see from the description, the number in the table referred to as millimoles of hydrochloric acid is actually the milliliters of a 100 millimole per liter, or 0.1 molar, hydrochloric acid aqueous solution. One more calculation shows that 25.7 millimoles of hydrochloric acid was neutralized. This is 11.4% lower than our calculation, which seems reasonable considering our calculation takes the reaction to completion. In the experiment, the weak bases of the hydroxides wouldn't have dissociated immediately, but over time the fraction of dissociated hydroxides react with the completely dissociated hydrochloric acid while being replenished by the hydroxides that had yet to be dissociated, resulting in an asymptotic function of the amount of hydrochloric acid neutralized. The experimental results would be a value of that function at a finite time, whereas we calculated the asymptote itself, or the value of the function at t equals infinity. So, from the experimental data, we have seen that by volume, neutralization capacity of malonol is mid-range. Acetylone is the most potent, owing to the neutralization power of magnesium oxide. Gaviscon is the weakest, but protects the esophagus with the power of seaweed, making it a specifically good choice to alleviate symptoms of gastroesophageal reflux disease, and Maalox comes in second place for potency. One last finding I would like to share is the interaction of some antacids with antibiotics. When taken at the same time, efficacy of antibiotics may be reduced. This seems to not be related to the potency of the neutralization capacity of the antacid. For example, in this experiment, ciprofloxacin absorption was reduced by 21.2% when taken with hydrotalcite, which was the largest reduction in the set, while hydrotalcite was far from being the antacid which had the most neutralizing capacity. Well, that's all. Thanks for listening.